Welcome. Previous class I have discussed about of chemical shifts. So while I am doing that uh, spectra, what I say that here we use that what amount of NMR, what is the magnitude NMR we are taking, that is operational frequency. Let's say we are taking that 400 megahertz instrument, and here we will write that what are the chemical shift values. And first thing is first here will be the one reference we will use reference. Then here that the ppm value will be there. Let's say xyz. This is the ppm chemical shift will use, and this will be the reference. This is the standard reference used. Now the question is why we use this standard reference. If we not use the standard reference, then what is the problems? So why you are using standard reference? So questions will arise. Questions will arise that why standard reference is used. First questions. And second questions arise that why TMS is used as standard reference. Why can't you use other? Why you are using? Is there any thing that can be used as a standard reference other than TMS? So that questions will arises while you are saying that standard reference is used and TMS is used in one NMR as a standard reference. Okay, now the question arises that why you are using standard reference, and if you are using TMS as a standard reference, then why you are using TMS only as a standard reference? Why you can't take other as a standard reference? Or what is the conditions that is needed to be used as a standard reference? Okay, so first question is why we need a standard reference in NMR. So we say that in different labs they are using different magnitude instruments as NMR. So some use the 60 megahertz NMR instrument, some use that 400 megahertz instrument, some use that 1800 megahertz instrument. That is depend upon that price. So if it is a high magnitude that has high cost, so 40 let's say 60 megahertz instrument, it cost is 1 crore, let's say approximately. And if it is 400 megahertz, then that may be cost 5 crore. And if it is 1800 megahertz instrument, that may be cost 10 crore. So that is depend on the cost, that how they actually how established their lab. If the lab is very established, they use that high magnitude instrument, because high magnitude instruments, that peaks you are getting, that is peaks are very good intense and they very clearly visible. So that's depend on the price. Okay, so let's say we have that 60 megahertz instrument, lab 1, let's say lab 1, and this is lab 2, and it says this is lab 3. 60, let's say 400 megahertz, and this is 800 megahertz. Cost like let's say 1 crore. Its cost is let's say 5 crore, and its cost is let's say 10 crore. Now the thing is that whenever you are using that chemistry lab, data will be like this. Okay, and wherever this is high magnitude, then it has that peak or intense peak. We will get intense peak, and this is medium peak. We will get medium intense peak. High intense peak. This is the low intense peak. Now whenever I am using this 600 megahertz instrument, so this is 60 megahertz, and this is 400 megahertz, this is 1800 megahertz. So peak will be somehow, I'm not using that reference standard, then peak will comes like this, and let's say peak is coming like this. Here, let's say if that, let's say CH3, CH2, Cl for a compounds. Let's take a compound. Let's say CH3, CH2, Cl. Here the two peaks will come. So two peaks will be there. So I will erase it. So two peak. This is for 3H. You get one peak, one signals, and this 2H we get another signals. And total we are getting the two signals. Okay, these are the two signals we have. So now whenever you use you characterize that this this peak position, this chemical shift for this, maybe let's say A, and let's say this is B, and for this let's say this X, let's say this is Y, and let's say for this whenever you are not using a standard reference, then its signals are A, B, and for this you will get a different signals, not A and B, you will get something other than A, B, X, Y. And here we use, let's say, some other, let's say that is, I will keep that XY, let's say here PQ, let's say you will get here AV. So if you are not using a standard reference, then the signals, this is that chemical shifts, that is in ppm, chemical shift in ppm, chemical shift in ppm. What we see that if you are not using a standard reference, then in different instrument we are getting a different signals, different chemical shift. Let's say here PQ, let's say here XY, let's say here AB. It means let's say here that 2 ppms, and here you are getting that 4 ppms, and let's say here you are getting that 6 ppm, and let's say you are getting here that 15 ppm, let's say you are getting that 3 ppms, and here we are getting that 8 ppms. So different instrument we are getting a different chemical shift. It means that same molecules you are using to characterize in a different labs, and in different labs we are getting the chemical shift value is different. It means that it is very hard to characterize a molecules. Either we have to use that same molecules, same NMR with same magnitude, so that everywhere you get that 3 ppm and 8 ppm, here also 3 ppm and 8 ppm. For that everywhere you have to use this 800 ppm, so 800 megahertz all case. Okay, but it is a very tough to use every instrument as same magnitude NMR. Reason is the cost effective. See that for using a 1800 megahertz instrument we have to spend 10 crore. Okay, so it is very tough to the labs which are newly established. They can't afford this high cost lab, high cost NMR, because they have some other expenditure also. They have to spend other, they have to buy other instrument, they also use their that money, so they can't use this 1800 megahertz instrument if it is newly established. So this is the reason on the cost, so they will not use all of the same instrument. Okay, so if they are using different instrument in different labs, then they will get that different chemical shift. So it is very tough to characterize a molecules. Some lab will say that this molecule have this chemical shift, somebody says this, somebody this shift. So this is very tough to characterize that characterize a molecule. So to normalize that chemical shift values, so that every labs will get the same chemical shift even if they are using a different magnitude instruments. Okay, so even if they are using different magnitude instrument, then also they will get that same peak. For that they use a standard reference which normalize the peak and give the same peak. So how they get the same peaks? Let's say if I'm using, so you are using the 60 megahertz instrument, and here using that 400 megahertz instrument, and here you are using that 1800 megahertz instrument. This is we say that lab 1, this is the lab 2, and this is the lab 3. Okay, now let's say that we are using any standard reference. We are using the standard reference, then that is TMS. Okay, this is the standard reference. Now what we say that ppm is hertz upon megahertz. So here we are using the 60, here we are using that 400, here we are using that 1800 megahertz. So whenever you are using a standard reference, so everywhere the standard reference is there. Now the peaks will come here. Peaks are there for characterizing CH3, CH2, CH. So suppose you are characterizing these molecules. Okay. So now the two peaks are there. So these two peaks has come. Now if you are using standard reference, then what you say that this is hertz upon megahertz. So this distance will be that whatever that standard reference you are using, whatever the magnitude you are using, so this frequency will be that 60 hertz. So everywhere you are using that same 60 hertz, and here we are using that after this whatever that is 400 means 400 hertz. Okay, so here you are 1800, so you are using that 1800. So after chemical shift value, okay, so this is 1800 and this is again 1800. So likewise 1800, 1800, 1800, 1800, 400, and this is 60, 60, 60. It means that whenever you are calculating the chemical shift value, so this ppm will be hertz upon megahertz. So hertz is, this is 60, and this using instrument that is megahertz is again 60. It means we are getting that here that 1 ppm, that is 1 ppm. Okay, now if you are using here for here to here, this is 1 ppm, and now here to here, that is 60 plus 60, that is 120, that is 120 upon that is 60 again. So this will cancel, this is going to be 2 ppm. So this is going to be 2 ppm. Similarly for this case, we will look that this ppm, this is parts per millions. So here everywhere that precision frequency is 400, 400, so this is 400, and using instrument also 400. So again you are getting that 1 ppm. So this is again 1 ppm, and for this case that will be how much ppm. So 400 plus 400, that will be 800, and using instrument is 400. So this is again you are getting to 2 ppm. So this is also going to be 2 ppm. Means this is either you are using 60 megahertz or you are using 400 megahertz. Both the cases that chemical shift value is, we are getting the same values. Here also 1 ppm, here also 2 ppm. Similar way here also we will get, this is 1 ppm and this is 2 ppm. So if you are using a standard reference values, even if you are using a different magnitude NMR instrument, then also we are getting a same peak value for a same molecules. It means that the chemical shift is normalized. So by using a standard reference, we normalize the chemical shift values. Okay, not that this ppm means parts per millions. Parts per millions, that is 10 to the power 6. Okay, so this is the reasons why are you using the standard reference, so that even that according to your affordable, we can buy a 60 megahertz or 400 megahertz. There is no problem in the chemical shift, because that will be normalized by a standard reference. So standard reference helps to normalize the chemical shift values. Okay, so now the questions will come that why you are using TMS as a standard reference. What are the conditions for using any compound as a standard reference? So now the question is why we using TMS as standard reference. So TMS means tetramethylsilane, that is silane, and tetramethyl means here CH3, 4 CH3 will be there. This is tetramethylsilane. Okay, so here we see that in this tetramethylsilane, so what things are there? These all are homotopic, so and all are same. So total is 12 H will get that one signal. Okay, so this 12 H will get one signal, and that one signal is here. Okay, so this is due to 12 H. This is due to 12 H, one signal you are getting, so that signal is here. Okay, so what we are understand from TMS is that 12 H is there, and that is giving one signal. It means that 12 H that giving one signal means it will be intensity is high. Intensity is high. So why you are using TMS as a standard reference? Reason is here that 12 H is there with same protons of 12. They are giving that one signal. It means that intensity is high. Intensity is high. So that even if you are using a very low amount of these products, if you have low quantity about amount of TMS, then also this will be give a good signal, so a good intensity. So that low quantity of TMS is taken, then also a good intense peak obtained, because it is from 12 H we are giving one signal, and that is intensity high. So we need to take very low quantity, so that we no need to prepare more and more. By taking low quantity, we can easily characterize our molecules as by taking this as a reference. So we take such type of compounds as a reference, so that we will take very less amount of that compounds, and even if we are getting even if we are taking a low quantity of that compound, then also we are getting a good peak as a reference that will help to other peaks to characterize easily. So that should give a very good intense. Okay, so the first reasons is that it will we have to take very low quantity of TMS, then also we are getting a good peak, so that it is easily used to characterize other signals. Okay, this is the first reasons. And second is it is inert. Okay, so not react with our compound, not react with our compound. Okay. So if the compound is react to our compound, then our compound will get affected. So we take the reference to such a compound which is inert to our compound, so it is maximum inert. Okay, that's why you take this as a reference. And third is it is volatile. Means that it has low boiling point. Why so why we take volatile compounds? Because if it is volatile, then at a low boiling point also, that water whatever that solvent will come, that easily evaporated, and our this compound again recover. Means that our which we are taking as a TMS, which we are taking as a reference, that will be we can easily get recovered. Okay, so if it is volatile, so if any compound satisfy this type of conditions, then we will take that as a reference. Okay, so that is the reasons why we are taking TMS as a reference, because it is a very high signals you will get even if you are taking a very less quantity of compounds. So That is the reasons why we are taking TMS as a reference in 1H NMR. So in 1H NMR and 13C NMR, the TMS is taken as standard reference. Okay, so today up to this, next class we will discuss more. Thank you.